Alright, hello. So what I'm trying to do is a few little how-to videos, things that I want to point out that may be confusing. At first I want to talk about really predicting ionic charge and how we write ionic compounds. And so the first thing we need to know are what are ions, which are charged particles, okay, that form when an electron is gained or lost from an atom. And so we can have cations or we can have anions. The cations means that we have ions with a positive charge, which means they lost an electron. Each electron is worth -1. Each proton is worth a +1, and so if you lose an electron, you're now going to have a positive charge on that atom. These are going to be found on the left side of the periodic table, and the loss of 1, 2, or 3 electrons can be denoted by either +1, +2, or +3. Sodium atom loses an electron, it now has an overall charge of +1, and we have the sodium plus ion. The opposite for anions. These are ions with a negative charge, which means they've gained an electron. These are on the right side of the periodic table. And you can either have -1, -2, or -3 charge on those atoms. So for the chlorine atom, if we lose an electron, if we gain an electron, we now have the chloride ion, Cl-. So what about predicting ionic charge? How do we know the charge of these different atoms or ions? Well, really, the way to think about it is everything wants to be like the noble gases over here on the right side of the periodic table, which is group 8A. So everything on the left has more than enough electrons, and so they want to lose electrons. So they are going to form positively charged ions. Okay. Everything over here on the right needs to gain electrons in order to be like the noble gases. The ones in group 7A just need to gain 1 more electron, and they would be just like the noble gases. The ones in 6A need to gain 2 more electrons to be like the noble gases. And so we can predict the charge just based on what group that these different atoms and elements fall into. Now we can also look at just memorizing the different cations and anions, which you do need to do for the exam. And so you can memorize a lot of these, which if you just think about what period or what group they're in, you can then determine the charge on those cations or anions. So here are the anions as well. Lastly, we can talk about forming ionic compounds. When we form ionic compounds, it means that really we're taking a metal and a non-metal and combining those, like sodium and chlorine. What happens is sodium wants to lose an electron to be more like the noble gases, so it forms the Na+ ion, whereas chlorine wants to gain an electron, so it can be more like the noble gases in group 8A, so it forms the chloride ion. That electron can be passed from sodium to chlorine, and basically you have a positively charged sodium ion, a negatively charged chloride ion, and these are attracted to one another, and they form what we call a lattice. Now lastly is the question of how do we write the empirical formula of different ionic compounds. And there's really 4 steps, but it's a lot easier than that. Excuse me. So the first thing we need to do is look at basically what we're combining. So here we are combining magnesium and nitrogen, okay, to form an ionic compound. Well, if we look at magnesium, we first need to determine what is the charge on magnesium for the ion. Well, magnesium is found here in group 2A, which tells us it has a 2+ charge. Nitrogen is found over here in group 5A, which means it needs to gain 3 electrons in order to be just like group 8A. So it's going to form the N3- ion. So if we write those out, we have Mg 2+, we have nitrogen 3-. Now all we do is move the charges from the superscript on each of the cation and the anion and move it to the opposite as a subscript. So the 2+ for magnesium now is placed as a subscript on the nitrogen. The 3-, or the 3, is now placed on the subscript of the magnesium, and we form Mg3N2, okay, magnesium nitride. There's a couple little rules here. So the charge on the cation becomes the subscript of the anion. The charge on the anion becomes a subscript on the cation. If those subscripts are not in the lowest whole number ratio, then you need to divide by the greatest common factor. And if the charges on the cation and anion are equal, then the subscript on each ion is 1. So that's it for this how-to video.